This is the question in which we have to find the detect the cycle in the directed graph and using the DFS method here. So like unlike the our previous problems in which we have to find the detection of our cycle in undirected graph. Now what's the scenario, like how the scenario changes in this question. Okay, so let's say I'm taking the very popular example for this case. Let's say if I have the sum of the nodes there, let's have simply denote this by can use this. Okay, so let's say there's a simply 1 there, there's a 2, and there's a 3, there's a 4 there. Okay, so the 4 nodes are there, and let's say there is a 7, there is a 5 there, there is a 6, this is a 5. Okay, and there is a 3 nodes remaining there, there is nothing, that is nothing but the our 8, and there is a 9, and there is a 10. Okay, now let's say if I'm since this is a directed, so it is direction, it is not direction. So I use that this is to showing the direction for this nodes there, like this is, so 5 is directed towards the 6, 3 to 7 there, and 7 to 5 there. Similarly it has to directed in such a manner there. Okay, and like it is. Okay, now since if I'm generally asking you, like brutally asking you, like how to check like if there any of the cycle present in this. So we are seeing the like yeah, there is the cycle that is present, it nothing but the 8 to 9 to 10. So this is nothing but the cycle, so we have to simply return the true in that case. Okay, now coming to this part, is it a cycle? So if I'm trying to traverse in along the cycle or along this curve there, so there's a 3 to 7, then 7 to 5, but now the 5 to 4, there's a no edge there, because this edge is simply goes from the 4 to 5, this is nothing but 5 to 4, this is not from the 5 to 4. Okay, so it means we don't traverse from that direction. Let's say we have to imagine in that direction, so 3 to 4, okay, 4 to 5, okay, but 5 to 7, again there's a path breakage, because 5 to 7 not edge direction there. So it means it is not a cycle, but there's a cycle there. Okay, so it means we can say there's a cycle of this, but it is not the cycle for the case. Okay, now coming to the question here, we seen in our previous videos, like whenever we have to see in our path, if we have to see any of the visited vector that is not our the parent, it means simply return the cycle there. Okay, now checking whether it is also valid in this case or not. Okay, let's say if I have to traverse from this one, it goes to this 2, it goes to the 3, then 4, then 5, then 6. Okay, let's say if I'm to make the small dry run for this part. Okay, so let's say there's a DFS calling for the, if I'm to just minimizing. Okay, so I'm to write this, there's a DFS call 1, it goes for the DFS of 2 there. Okay, now it goes for the DFS of 3 there. Okay, then it calls for the DFS of 4 there, then it has to call for DFS of 5, then it has to call for the DFS of 6. Okay, 6 there. Okay, now after it there's nothing remaining there, so it means these are calling in such direction, they are like I don't have to represent. Okay, so there's a, but in DFS 6, so the like there's a node remaining there, it means it has to now what it can do, DFS 6, it simply return to this 5, it has to return to force meet, we have to simply the backtrack. Okay, means we are extending to this part, but there's the ending reaching there. So now tracking whether there's all of the remaining node. Okay, so 6 return to 5 means we have to now, since we coming to this direction, means we firstly we have to come to this direction, now we have to backtrack our like a part there and check in another path there. Okay, so 6 to 5, okay, we comes to here. Now 5 to 4, we come to here. Now 4 to 3, we have to come to here. Okay, now we have to arriving at 3 position. Okay, so since we have to cover this direction, now let's say during these directions there, we have to make these as visited. Okay, now we have to, when we are arriving to the, there's another the path there, means DFS of 3, it can call to DFS of 7. there's another configuration of like how this is going there. I don't know how it is. Why it is showing there frame. Okay, so there's a okay, so DFS of 3, like I think again, oh, the upper part is also remaining there. Okay, so DFS of 3 in the different path, it has to call for the DFS of 7. Okay, now it has to call for the DFS of 5. Now the interesting part arises there. Since it has to call for the DFS 5 and 5 is already visited in the case when we have to cover this path, so it means if it is thinking that 7 goes to 5, it is already visited and it is not the parent, it means we have to detect the cycle, means we can return the true. But if we are following this approach, so it simply the wrong process here. Now see, like what's the contradiction or what the conflict between this. So see, there's a one tricky point there. When first we have to come to this path, let's say if I have to assigning this a path as a 1, so when we have to come to this way, they okay, now during the backtracking we simply make these as an unvisit. Okay, now there's a, when we go to the another path there, so I'm just naming this as a 2 there, means it is goes along to the 1 2 3 7 5 6, and for our previously path is going to the 1 2 3 4 and 5 and 6. Okay, so now when I'm after arriving the path number 1, when we are arriving to the during the path number 2, so on reaching to 5 number to node number 5, so this is not the same data arriving to our previous path, because now this is a different path as compared to our previous path. So now I can think you are understandable. Previously I have to come to this path. Now if I am using this path here, so don't confuse with this node. We have to also see if it is visited in the same path. Okay, so what it means, so now like simply first like in previous cases we have to use our visited vector to make any other vector, or we can to track our the visited visit status of any other node. But now we also have to concern about like what are the visited node in our the current path there, means let's say if I'm running at this path, so I have the major concern about what are the visited node only in that path there. Okay, so if I am reaching any of the node in the current same path, so only in that case we have to return the cycle. Let's say if I am coming to this dry running for this, whether it can return true or not. Okay, so if I am calling for the DFS of 8, okay, so it has to return the DFS of 9. Okay, and so it has to call to 9, then it has to call for the DFS of 10. Okay, now DFS of 10, when it goes to its neighbor, so it has to call for the DFS of 8, that is visited and that is not the that is also in the same path and that is not the parent. It means it has to return the cycle here. Okay, don't confuse it like how to do this in mid value. We have to how we call the DFS in mid value, because for to adjust our the multi components logic, we have to simply traverse for all of the, we have to check for all of the nodes. So that's why I have to call for the DFS of 8, and he'd see when it goes to the DFS of 10, when it goes to the 8, it is already visited, and it again that it is not the parent there, and also in the same path, so it means we have to return the cycle is detected. So now we can think like in the what are the extra things we have to check for these cases unlike our the previous cases. So we can say one thing here, we can say let's make it okay, so we can say during our DFS, if we have to revisit a node there, we can say we have to revisit a node that is already in now I'm majorly emphasize on this part. This is nothing but the currently recursion path. Okay, if I'm revisit a node that is already in recursion path, that is nothing but the current path. Okay, so only that case we have to return the cycle is detected here. Okay, so what it means, now in this case we have to simply maintain the two cases there. Now we can see we have to maintain the two cases two arrays there. one is the for our the visited vector there, and again the another vector, this is nothing but the path reserve vector. So that is the simply give me the node has been visited or not. Okay, and this is for the node is in the current path or not. Okay, so I can like simply write what's the why is the use of these two there. So let's write this in our in front of this line. So it has to check that node has been visited, like in the previous it is visited or not, or this is for node is in current path. Okay, current path or current DFS path we can say. Okay, now like so this is the main logic, main intuition behind this question. Now coming to the cycle condition, like we can say if our neighbor is visited and the neighbor is now what we can say, if our neighbor is visited and neighbor is also in pathways, so in that case we can say that we have to detect our cycle there. Okay, we can say we find one cycle here. So that's the main intuition, or that's the condition, and like how to check the condition in this directed and like in the undirected cases there. So now coming to this, so like what's the approach, we know very well. Like first of all we have to traverse all of the nodes. And what are the nodes? That are the, because the graph map that disconnected, so that's why I have to traverse all of the nodes. You can say for each of the unvisited node, for each of the unvisited node there, simply run the DFS for this node. And what's the do in this DFS part? First of all we have to mark our, we can say we have to mark our the visited node as 1 there. And like first okay, so and in the DFS we have to mark our the visited node as a 1 there, and we have also mark our path width of node as 1 there. Okay, simply explore what are our neighbors there. Okay, now what we know very well that why it is okay. After it we can say if it is not visited, so in that case we simply can do what we can do, simply do recursion. Okay, and if it is visited, so in that case, and if it is visited and also in same path, so it means simply the cycle is found in there. Okay, and like after DFS we have to simply, or like after completing this DFS, because we have to also backtrack this part. Okay, because when we have to reach this part we have to go to the other part. So what we can say, after DFS, when we are to, when like this is a more concerning, more important part in this question. When we are, let's say after completing this path, when we backtrack from this path, because DFS is calling in to this manner, this top to down, when this is returning this means we have to unvisit that part. So during the unvisiting, like in previous cases, we don't have to make our visited as become the unvisit, but in that case we have to make our path width as become as 0. So what it means, the, let's say if I have to backtracking, let's say 6 is coming to the 5 is coming to the 4, so like so these 5 and 6 are not in the further in the current path there. So to make or to remove the status of these nodes, we have to simply update our pathways. Like how to update this, simply make this mark value as 0. So that means they are not in the current value, still they are visited, means in our previous, in like in our past we have to visit that. But if our path width is 0, so it means we have to cover or we have to visit this in our past, but in current path it is not visited. Okay, and since we have to find the cycle, it means it should be the in our current path there. Okay, so now coming to the coding part there, so I think this is completely like clearly there. This is the means function there. We have to mark our visited vector. Our path visited vector is simply initialized with 0 because all of initially are unvisited there. Traverse for all of the nodes there. If any of the unvisited nodes, check whether if any of the DFS is returning true, means we are able to find the cycle, simply return true. If not able to find any of the cycle there, simply returns false. Now coming to the definition of the DFS. So what are the parameters I pass here? Simply the what are the there's a current node, visited, pathways, and adjacency list. First of all, arriving at the node, make its visited as a 1, pathways as a 1. Okay, and let's just skip that part. After complete exploring all of the neighbors, make as when we have to backtrack this part. So this is nothing but the backtracking process. So make the pathways as node as 0 because this is nothing but the for removing this, and simply if we are not get from this, simply return the false. Okay, now coming to this neighboring part there, traverse all along the neighboring part. If this is not visited, so go to DFS for its neighboring part, and let's see if any of the future, if any of the neighboring DFS returns true. So that means when we go to its neighboring part, and in future if it returns the true, simply return true, means we are able to detect. And the other thing is, when we are going to the visited, since this is for the unvisited, when we are going to visited, and if pathways of IT is, or we can say the pathways of neighboring is 1, means it is already visited and it is also in a current path. What I can write it here, this is for the case when it is unvisited there. Okay, now coming to this path, this is the for the visited, we can say this is for the visited and in same path. Okay, so I am checking for this in same path. We also have to return true for in this case, and I have to discuss this already. Okay, so this is the simple coding for this, and this is a simply DFS code. You know very well like what's the time complexity and space complexity. So the time complexity is nothing but the of V plus E there, and now coming to the space complexity is nothing but there's a recursion stack there, and there's one visited for the this visited and this path visit. Okay, so totally is, we can say, so it is approximately so of V there. Okay, so yeah, we can always say that what are the cycle in directed edge, it is nothing but the how we do the back edge detection in this case there. Okay, so that's the question here.